Hi everyone, so here are your notes for 1.4, angles and angle relationships. Now, in this particular video, we're going to focus mostly on angles, and then in part 2, we will talk about angle relationships. So, the first thing I want to mention, or rather the first thing we need to take care of, is all of these new vocabulary terms that you're going to see. The first one being angle. What an angle is a measure of rotation in degrees. Right? You've heard of this before, where spinning 180 degrees is like spinning half a circle, and spinning 360 degrees, right? So if I were to say spin around a particular point all the way around, that is 360 degrees. All right. Now, what they are made up of is two rays that share an endpoint. So let's go ahead and let's draw that. So I'm going to go ahead and select my endpoint first, and because my rays share the same endpoint, they're both going to come from this endpoint and go in different directions. All right, so let's go ahead and let's give 2 more points. I'm going to go ahead and name this A, B, and C. All right, let me go ahead and zoom into the picture, because what we're going to do now is we're going to name this angle. And there are actually many different ways to name it. The first one is the way that I prefer. And that is using all 3 points. And the order in which we use the 3 points has to be the way you trace the angle. So I can start at A, go to B, and then end at C. Or I could start at C, go to B, and end at A. Notice that if I start at point B, and then I go to C, and then I go to A, what happens is that from C to A, there's no connection. There's no line there to connect point C and point A. And so what I'm doing is I'm jumping across the angle, and I can't do that if I'm trying to name it. So when I name the angle, I need to make sure that my pen or pencil traces along the angle in order. So one way to name this would be the measure. I'm sorry, not measure. This would be angle ABC, or angle CBA, really up to you. I could technically also name this angle B. Now, I don't particularly like naming an angle with one letter, because when you'll see later on, especially when we talk about angle relationships, is that there will be angles that share what's called a vertex. The vertex is like the corner, or the point where your angle begins. So this right here is your vertex. And if it's a shared vertex, or in other words, there are more angles that use point B, I cannot name that angle with angle B, because then I don't know specifically which angle I'm talking about. All right, I almost forgot to mention, we also have something called the sides of the angle. And that is the two rays that come out from the vertex. All right. The last way that you can name an angle is if you say a number on the inside. Now, notice how back here I wrote 360 degrees, and you see the little dot symbol kind of on top of the number. If you see this degree symbol on the number on the inside, that represents the angle measure, not the name. So just keep in mind and be careful when you see the numbers on the inside. But because this is a number with no degree symbol on the top, I can go ahead and use this number to name my angle. So this angle can also be called angle 1. All right. Let's go and move on to the next vocab word. Now, I am going to skip an acute angle, mostly because I want to talk about the right angle first. All right, so what a right angle is an angle that measures exactly 90 degrees. Can't be a little bit more, cannot be a little bit less. It has to measure exactly 90 degrees. Now, what that looks like is if I were to have an angle, and it basically looks like the corner of a box. So here is one ray. Here's the shared endpoint. This is a right angle. And the other way that you can tell from a picture, even though it doesn't say that it is 90 degrees or that it is a right angle, is you see this mark, which is a little box on the inside of the angle. If we see this mark, we can go ahead and safely assume that this angle is a right angle. Let me go ahead and give it a couple more points so we can name this angle correctly. Let's go ahead and call this angle S, T, and R. So we have that angle STR is a right. I will abbreviate that with RT and angle. Okay. Again, the important thing to note is that a right angle measures 90 degrees. All right, now we can go ahead and move back into that second vocabulary word that I skipped, which is an acute angle. An acute angle is an angle that measures less than 90 degrees. Okay. All right, so if I say have an angle here, and it looks like this, let's go ahead and let's use our numbering. So let's call this angle 2. And let's say that I know that the measure of angle 2 is 63 degrees. If I know that the measure of angle 2 is 63 degrees, that means that angle 2 is an acute angle because it is less than 90 degrees. Okay, relatively straightforward, I would say. And of course, if we have an angle that is exactly 90 degrees and an angle that is less than 90 degrees, well, then the last category is an angle that is more than 90 degrees, and that would be considered an obtuse angle. So let's go ahead and write that down. An obtuse angle is an angle that measures more than 90 degrees. And here's where I need a second condition. And less than 180 degrees. Now, some of you might already know this, but when an angle is 180 degrees, it forms a straight line. And so that's why for an obtuse angle, it has to be more than 90 degrees, but it has to remain less than 180 in order to be obtuse. So what that looks like is something like this. I can go ahead and create my vertex first. Here's a ray. Here's another ray. Let's go ahead and call this angle MNP. And the measure of this angle is going to be 120 degrees. Now, because the measure of the angle is 120 degrees, we know that angle MNP is an obtuse angle. Right? Based on the definition. 120 is greater than 90, but it's also less than 180. All right, the final angle category that we need to consider is, of course, the straight angle. And it is an angle that I've mentioned already, but now I'm giving it a name. So a straight angle is an angle that measures exactly 180 degrees. Okay. Now, this looks like a line, but again, keep in mind that angles measure rotation. And here's what I mean. Let's say that I have hands of a clock, right? So let's pretend I have a clock right here. Here is the center of the clock. All right, so right up here is going to be 12 o'clock, and down here is going to be 6 o'clock. If both of my hands started right up here at 12 o'clock, so let's say midnight, one hand is going to rotate until it gets to 6. And once it reaches 6, we have this straight line. But the rotation from where it started at 12, it started pointing at 12, but now it's rotated down to 6. This rotation is 180 degrees. So that's why, even though it looks like a line, the straight angle isn't actually a line, but what it measures is that rotation, that movement. So if I were to give this a name, let's go ahead and give these rays a couple more points. Let's just go ahead and call this PQR. So I have angle PQR, and it is a straight angle because it measures 180 degrees. All right. Final vocabulary for this section is going to be an angle bisector. Now, we have definitely seen this word bisector before. If you can recall from when we were talking about segment bisectors, this is something that cuts whatever it is that it's cutting into two, right? Because BI, meaning two, congruent parts, right? Like sector, section cuts into parts. And because it's called an angle bisector, it cuts the angle into two congruent parts. So here's the formal definition. This is a line, ray, or segment that cuts an angle into two congruent parts. So let's say I have an angle like this one here. Let me go and draw in the shared vertex. And let me go ahead and draw in another ray that kind of splits this angle in half. Now, or in two congruent parts. Let's go ahead and just call this quickly. This is A, B, C, and D. Now, if the problem tells me that ray BC is an angle bisector, then what I know and what I can conclude from that is that angle ABC is congruent to angle CBD. Let me go and write down that statement, which says that angle ABC is congruent to angle CBD. And what you'll notice is that I marked the angles with these two arcs. We have markings for congruent angles in the same way that you had markings to show congruent segments. So depending on the number of lines or arcs that you see, that tells us, or that will signify to us, which angles are congruent to which ones. All right, so I think that's really it for our vocab. Now we can go ahead and take a look at our first examples. All right, so for example 1, it's asking us to identify whether the angles below are acute, obtuse, right, or straight. And they want us to write a complete sentence for each one. Now, they don't tell us that we need to give an explanation, but I'm going to go ahead and give the explanation anyways, just for good practice. So, taking a look at the angle in problem A, I'm going to go ahead and first name the angle. And remember, I need to make sure that I trace along the angle and I don't just jump across the opening from one point to another. So I can name this angle BRH or HRB. So angle HRB is, and it's going to be an obtuse angle because it measures 133 degrees. Notice again that little dot symbol. This tells us that this is the measure of the angle and it's not the number or the name of the angle. And because it's 130 degrees, 33 degrees, it's more than 90 but less than 180. So angle HRB is an obtuse angle because it measures more than 90 degrees but less than 180. Okay. All right. Part B. Part B, we have angle PWM or MWP, and it tells us that the measure of the angle is 90 degrees. Now, one thing that the picture or this problem didn't do is write in that little box to signify that I have a 90-degree angle. But because I know this, we can say that the measure of angle PWM is a right angle because it measures exactly 90 degrees. All right, moving into part C. I have angle KVE or EVK, and it tells us that the measure of this angle is 50 degrees. Well, from our vocabulary earlier, any angle that measures less than 90 degrees is called an acute angle. So angle KVE is an acute angle because it measures less than 90 degrees. All right, and then last but not least, we got part D. Now, part D, I have angle FUN or NUF, and it measures 180 degrees. And because it measures 180 degrees, we know that angle FUN is a straight angle. Again, because it measures exactly 180 degrees. So now that we were able to identify all of these angles, now we can start doing a little bit of algebra and a little bit of solving using these angles. All right, now very quickly before we jump into our examples, there is something called the angle addition postulate, which is very similar to the segment addition postulate that I want to talk about. So if point A is a shared vertex, and this is what I was talking about earlier about angles having shared vertices. So if point A is a shared vertex, then I have angle CAD, and I also have angle DAB. Now notice that I marked these two angles with not just different colors, but different numbers of arcs. And again, this is to signify that these are not congruent. In other words, the measures of these angles are not the same. But I have these two angles, and they not only share a vertex, but they actually form together the whole angle CAB. So what that means is that if I take the measure of angle CAD, the one I marked in red, and I add the measure of angle DAB, the one I marked in blue, this will give me the entire angle. The measure of angle CAB. In other words, this angle right over here. So again, very similar to your segment addition, but instead we are adding angles this time. All right, let's go ahead and let's go over our last set of examples. So in example 2, it says to write an equation that uses the names of the angles. Just like we did before with names of segments, now we're using names of the angles instead. And then they ask us to substitute and solve for the indicated angle. So in part A, it's asking us to solve for the measure of angle ACD. So here is angle ACD. As we can see in the picture, ACD is the whole angle, and I can mark it like so to remind myself. Now, because it's the whole angle, it's made up of two other parts. Those two other parts are the 52 degrees and the 97 degrees, and I have to name both of these angles. But let me go ahead and write down the whole angle first, which was the measure of angle ACD. And to find the whole angle, I'm going to add ACB together with angle BCD. And again, that will give me my entire angle ACD. Now it's just a matter of substitution. So the measure of angle ACD is going to be equal to 52 degrees plus 97 degrees. Adding these together on a calculator, we get that the measure of angle ACD is going to be equal to 149 degrees. All right, let's go ahead and move on to part B. Part B tells us to solve for the measure of angle KLM. So if I trace out KLM, here's K to L to M. Oh, it's actually this little missing piece right here that has no angle measurement. So let me go ahead and mark that in the picture. Now, what I do have is this green arc that measures 121 degrees, and this green goes from JL to LM. So This 121 degrees actually represents the measure of angle JLM, which is the whole angle. And I'm given a part of it, angle JLK, which is 181 degrees. So if I'm given the whole and I'm only given one of the parts, well, we can do some subtraction to find what's missing. So let's go ahead and write that down. The measure of angle JLM, which again is the whole. Oops, let me use the appropriate colors here. So the measure of angle JLM minus one of the parts, which is the measure of angle JLK, is going to be equal to the leftover part, which is the measure of angle KLM. So substituting in, we have 121 minus 81, and that is the measure of angle KLM. 121 minus 81 is 40 degrees, which is our missing angle for the measure of angle KLM. All right, let's go ahead and let's take a look at our final example. So it's asking us to solve for the measure of angle DEG. So here is angle DEG, and it tells us if ray EF, here is ray EF, is an angle bisector. Now, from our notes earlier, we know that an angle bisector is something that cuts an angle into two congruent parts. So those two congruent parts are actually going to be angle DEF and angle FEG, right? Because the whole angle DEG has been cut into two smaller angles, but those two smaller angles are equal or are congruent to each other. So we can go ahead and we can actually write that down as an equation. So I have the measure of angle DEF, and this has to be equal to the measure of angle FEG, because again, these two angles right here are congruent. Now we can go ahead and substitute in what we know. The measure of angle DEF is 2x plus 10, and the measure of angle FEG is 4x minus 3. Now we can just use algebra to solve. Subtracting 2x on both sides in order to get all my x's onto one side. My 2x's on the left side cancel out. I'm left with 10 on the left side is going to be equal to 4x's minus 2x's leaves me with 2x's minus 3. Adding 3 on both sides. My 3's on the right side now cancel out, and I'm left with 13 is equal to 2x. Finally, dividing by 2 on both sides, we get that x, right, because our 2's cancel out, so I'm left with x on the right side is equal to 7.5. Now, keep in mind that we are not done after solving for x because, again, the problem is asking us to solve for the measure of angle DEG, which is the entire angle right here. So, in order to do that, if I want the entire angle, so the measure of angle DEG, this is going to be equal to the two parts added together. So the measure of angle DEF plus the measure of angle FEG. All right, now substituting in, the measure of angle DEG is equal to 2x plus 10 plus 4x minus 3. Combining like terms, I get that the measure of angle DEG is equal to 6x plus 7. Now, we can go ahead and take what our x was equal to and substitute it in. So we get that the measure of angle DEG is equal to 6 times 7.5 plus 7. Okay, so finishing this up, we get that the measure of angle DEG is equal to 6 times 7.5 is 45.5 plus 7. Finally, we get that the measure of angle DEG is equal to 52.5 degrees. All right, so that's going to be it for today. Thank you so much for watching.